Now, if we look at some of these overall reaction orders, we've got the fact that this is a 1 here, tells us the order is 1, and you've got your unit. All right. This is raised to the 1/2, and this is to the 1. So we have an order, overall order of 1.5. And again, we don't need this. You don't need to know for the AP. They've never asked for a fraction in rate order. Again, this is a 1 and a 1. So you have 2, and then again, the idea of m to the -1, s to the -1. If we look at an example, here's a reaction that's happened, and experimentally, we figured out the rate constant, K times NO squared H21, right? So we know automatically 2 plus 1 is 3, so the total reaction order is 3, right? Does doubling the concentration have the same effect in terms of NO versus H2? No, if we doubled NO, then our rate would increase 4 times because we've got NO squared. If we doubled that, we would have a 4 times increase in rate because it's second order. If we doubled the H2, because of the exponent of 1 in this case, then the rate will also double. And hopefully that Pogel exercise helped you to see this. And we'll practice it a little bit more with the later problems. Right, and the unit of K, we figured out it's third order, so we've got m to the -2, s to the -1. Now, if we were actually going to figure out the rate law, again, this is like the chem activity. We would choose experiments that we can compare where 2 concentrations are the same in one situation and different in the other. So if we look at A and B, and you'll notice that here, these 2 concentrations are the same. So they're 0.1 and 0.1. And notice here, they've doubled, all right? And notice what's happened to the rate. It stayed the same, it hasn't changed. So if we were actually looking at this the long way around by math, we could say rate 2 over rate 1 is equal to the K's for each of these. And let's let M and N be the orders for each of them. So A raised to the M, B raised to the N, all right? And so for the second reaction, we've got all of these over each other, and we're canceling the K values. Now notice the A's have stayed the same. So we've been able to cancel these, and we've got 0.2 over 0.1 to the N, right? And notice the rate is the same, so 4 by 10 to the -5 equals 1. We've got 0.2 over 0.1 is 2 raised to the N. So what factor of N, or what is the exponent of N that allows us to have a value of 1? It's got to be 0. So the reaction is 0 order. This is with respect to B, because B doesn't change the rate. Let's look at the next 2 experiments that we can compare. We notice now up here at the front, we've got B is the same, and you'll notice here A is doubling from 0.1 to 0.2. So, and I like to have the big numbers on the top. Let's see what's happening to the rates here. We have a 4 times increase in the rate. So if we have rate 3 over rate 1, we have 16 over 4, and that's 4, okay? Then we've got all of these equations for each of the rate laws. The K's can cancel, and then your B's are going to cancel. So we have A in the third experiment at 0.2 over 0.1 in the first experiment gives us 0.2 over 0.1, which is 2, and